My dear students, today we will discuss some concepts related to root locus criteria. In the previous class, we have discussed about some concepts related to root Hurwitz criteria. From that, we have discussed about the stability of the system. In fifth module, we have mainly three concepts. That is about the root Hurwitz criteria, the root locus criteria, and Bode plots. Only these three concepts. Using these three concepts, we can find out the stability of the system. From that we'll come to know, from these concepts we'll come to know the system is stable or not. Stability means important. In the previous video lecture I told about what is stability, why system should be stable, what and how we can find out whether the system is stable or not, or we discussed in that one. Today we'll discuss about the root locus criteria. In that, to understand the concepts related to root locus criteria, let us solve some problems. By solving problems we'll come to know how we can find out the stability of the system using root locus criteria. For example, we'll solve some problem. From that, solving one or two problems, we'll come to know the concepts related to root locus criteria. By using the concept of root locus criteria, how we'll come to know the system is stable or not. For example, first I will discuss one simple problem, so that we'll come to know how we can solve the problems related to root locus criteria to find out the stability of the system. One simple example, for example, for g of s, h of s equal to k into s plus 10 divided by s into s plus 1 into s plus 2. This is the equation, this is the characteristic equation, and they asked calculate angles of asymptotes and centroid. They asked to find out what is the angle of asymptotes and centroid. Asymptotes means the branches of the root locus which tends to infinity are called as asymptotes. Asymptotes means nothing. These are the branches which end in infinity, or which tends to infinity, are called as asymptote. Here is it. The branches which are approaching to infinity. Along the straight lines called asymptotes. Asymptotes means the branch. The branch. Already we have discussed so many concepts about what do you mean by branch, what do you mean by node, what is node analysis, what is mesh. So many concepts we have discussed in the network analysis. Now, they are given this equation. From that we have to calculate the angles of asymptotes and centroid. Here you know that in this equation the denominator term represents the number of poles. The numerator term represents the number of zeros. Therefore here the denominator poles, how many poles are there? There, so s s plus 1, s plus, totally there are three poles. Therefore how many poles? Three poles. How many zeros? S plus 1. In the numerator we are having only term associated with the s, therefore only one zero. Therefore s n equal to p equal to 3. Therefore 3. Therefore here p minus z, number of poles minus number of zeros. Here how many poles are there? 3. How many zeros are there? 2. Therefore 3 minus 2 3 minus 1 equal to 2. That is branches approaching to infinity. So two asymptotes are there. That is two branches which are approaching to infinity. The branches which approach to infinity, what we call nothing but asymptotes. So two asymptotes are required. Then how we can find angles of find out the angles of asymptotes? To find out the angle of asymptotes, some one equation is there. That is nothing but theta equal to 2q plus 1 into 180 degree divided by p minus z, where the values of q will be start from 0, 1, 2, 3 like this. First, what we'll do, we'll take the value of q as 0, substitute in this equation. Therefore, when q is equal to 0, this becomes 0. Therefore, we are left with 1, 1 into 180, 180 only. P is how much? P is 3. Number of zeros are how much? 1. Therefore, 3 minus 1, 2. Therefore, 180 by 2, that is equal to 90 degree. This is one asymptotus. Total how many asymptotes are there? Two asymptotes are there. Find out the angles of those asymptotes. For q equal to 0, 1. Second, we'll take the value of q as 1. T2 equal to substitute in this value. Substitute the value of q. Now substitute the value of q as 1. When we substitute the value of q as 1, 2, then 1 into 2, 2. 2 plus 1, 3. 3 into 180, 3 into 180 divided by p minus z. Number of poles minus number of zeros. 3 minus 1. Therefore, 2. Therefore, this is 3. 3 into 180 degree divided by 2. If you make multiplication and division, you will get 270 degree. 270. There's two asymptotes at the values of q equal to 0 and 1. Now we'll find out the centroid. How we can find out the centroid? The equation of the centroid is sigma equal to a summation of real parts of poles minus summation of real parts of zeros divided by p minus z. Therefore, here how many poles are there which are located? The poles are, when here in from this equation we will come to know the number of poles. First one, this one is s equal to 0. This is s equal to minus 1. This is s equal to minus 2. That is poles located s equal to 0, s equal to minus 1, s equal to minus 2. These poles and zeros are very important. You should understand all these concepts. Therefore, 0 located at s equal to 10 plus 10 means equal to the 0 will be s equal to minus 10. 10 s equal to minus 10. 0 is located at minus 10. Therefore, poles are 3. Their positions are like this. And in the here to calculate the centroid, here real part, and here there is no, here in this poles and zeros, there is no such 1 plus 1 plus plus or minus 1 plus j or 1 minus j, like some imaginary term is not there. All 0 minus 1 minus, these are real parts of poles, not imaginary part is not there. Even the imaginary part is there, therefore no problem, only we have to consider the real parts of poles. Already these are all real parts, therefore we'll calculate using this, we'll find out the centroid. So to calculate that one, substitute the values of poles. Poles values are what? 0, minus 1, minus 2. 0, minus 1, minus 2. Summation of all the real parts of the poles minus the summation of all the parts of the zeros. How many zeros? 1 0, and that value of 0 is minus 10. Substitute this value, therefore we will get minus 3 minus of minus plus 10. Plus 10 divided by 2 means 7 by 2. 7 by 2 is nothing but 3.5. This is nothing but the centroid. This is the location of the centroid. Therefore, graphically, how we can represent this angle of asymptotus and centroid? Value of this centroid is 3.5, and this is plus means in the s plane, this is the positive axis, this is the negative axis, this is the imaginary, this is the real, this is the imaginary axis, this is the real axis, and this is here, this is the right of the uh, 3.5 means here this minus 1 minus 2 minus how many poles are represented by cross marks. Poles represented by cross marks, one at 0, another at minus 1, another at minus 2. This is minus, this is represented by circle or some dot. This represents the 0. Already we know that 0 is there at location 10. At minus 10 location 0 is there. At location 0, minus 1, minus 2 poles are there. Therefore, the S plane will centroid is there at the pole here, right side inside, and that value is 3.5. This is centroid at 3.5. This is the centroid. From that, one angle is how asymptotus angle is, one is at what angle, 90 degree, another is at what angle, 270 degree, 90 degree and 270 degree. Therefore, Earth's interests are nothing but the branches, one at 90 degree, another is at 270 degree. 270 means this is 90, this is 180, 180, this is 270 means here we take this is 90, 90, 180, 270. Therefore, one branch this side and another branch, another asymptotus at the angle 270 degree. This is how, using the concept of root locus, we can find out the centroid and asymptotus related to root locus criteria. Now we'll discuss few more concepts related to root locus, so that we'll come to know how we can find out the stability of the system. With another example, we'll discuss in detail about how we can how we can discuss how we can find out whether system is stable or not. Now let us with a problem. For example, draw the approximate. With a problem we'll discuss how these are steps, general steps to solve the problem on root locus. Here already I told that you have to refer the book, some YouTube book or some good books related to control system, because so many concepts are there. Only I am discussing only some problems. Here you come across so many concepts. You have to refer the books, you have to refer the video lectures, you have to refer the notes. Then only you'll come to know the concepts related to the root locus criteria, Bode plot, root service criteria in detail. Therefore, there they are given the steps to solve problems related to a root locus. With an example, I will discuss how we can find out the root locus of a system. Root locus, from that will come to know whether the system is stable or not. They have given the equation with some problem. With a problem we'll discuss. Problem is what? Draw the approximate root locus diagram for a closed loop system whose loop loop transfer function is given by, this is the transfer function is given by g of s h of s equal to k divided by s into s plus 5 into s plus 10, and comment on the stability and draw the root locus diagram, and from that and also depending on the root locus diagram, and tell whether we have to tell whether the system is stable or not. Therefore, some steps are there, we have to follow these steps so that we can find out the root locus, and from that we'll come to know whether the system is stable or not. Therefore, step 1, we have to calculate how many poles are there here. From the expression only we'll come to know how many poles. 3 poles. Why? Because denominator term. Denominator tells how many, 1 pole, 2 second pole, third, total 2 poles, 3 poles. S is equal to 0, S is equal to minus 5, S is equal to minus 10. There are no zeros. Why? Because in the numerator term, no term like S related to S. Therefore, zeros is Number of zeros are 0. Number of poles are 3. Therefore n is equal to p equal to 3. Number of branches will be equal to 3. Therefore p minus z equal to 3. Since the number of zeros are 0, therefore poles are 3. The 3 branches approaching to infinity. The branches which are approaching to infinity, we call it as asymptotes. Starting points are s equal to 0, s equal to minus 5, s equal to minus 10. From these are the poles, location of the poles, the S plane, open loop poles. Then terminating points, all are terminating to infinity. Therefore, no open loops, zeros, so infinity. So sections of real axis. One breakaway point between 0 and minus 5 exists. Here suppose the explain. Suppose we denote the poles here. This suppose you think that this is the S plane. Here poles are there at what location? One is at 0, one is at 0, another is at minus 5, another is at minus 10, and all these poles are 10 to infinity. But here this pole, here this is having some pole in the left toward infinity. We are having one pole is there. For this pole we are having one another two poles towards the left side, which are terminating infinity. But what about this pole is not having any another poles nearby it to, so that it tends to infinity. Therefore the breakaway point, from this will come to know the breakaway point will be somewhere around between minus 5 and 0 and minus 5. Therefore they will tell sections of real axis, where real axis will be there, it is in between minus 5 and 0. There is one breakaway point between 0 and minus 1 exists. Some breakaway point will be there in between minus 5 and 0. Breakaway point means one particular point where from that we will find out the root locus, where we can draw the root locus. Then that is the breakaway point. Now we will calculate how the breakaway point. How, before that we will calculate the angle of asymptotos. Angle of asymptotos, we know the equation. From this equation, theta equal to 2q plus 1 into 180 degree divided by pi minus z. Therefore total here values of q may be 0, 1, 2, like this, 3, 4, all integer values. Here first we'll find out theta equal to 1. First place the value of q as 0, then 180 by 3. Why 3? Because total how many poles are there? This is 3. Last time we got in the example we had discussed p minus 3 minus 1, therefore 2. But here number of zeros are 0, therefore we will have the number of poles are 3, therefore we will divide by 180 by 3. 180 by 3 is nothing but 60 degree. We'll find out one more angle of asymptotos. One more angle of asymptotos is uh, in this replace the value of q as 1. Therefore 1 into 2, 2 plus 1, 3, 3 into 180 degree divided by 3, 3 3 cancel, therefore it is 180 degree. Then theta 3 equal to, place the value of 2 in this equation. Q equal to 2, 2 into 2, 4, 4 plus 1, 5, 5 into 180 divided by 3. From this we will get the value of theta 3 as 300. Therefore totally how many asymptotes? 3 asymptotes at the angles. Therefore angles of three asymptotes required for 3 branches approaching to infinity. Therefore next step is centroid. Now we calculated the angles of asymptotes. Then we have to find out the step. Now according to step number 4, we have to find out the centroid. Centroid will be equation to calculate the centroid is nothing but sigma equal to sigma equal to sigma equal to summation of real part of poles minus summation of real parts of zeros divided by p minus z. Here all values, all poles are real parts, no imaginary parts. Therefore directly we substitute the values of poles here. One is at 0, one is at -10, one is at -10, and therefore p is how much? 3. Zeros are not 0 anything, therefore -15 by 3. Therefore -15 by 3 gives the value of centroid as -5. Centroid is very important. From that we can find out the we can find the diagram for root locus. It is at 5. At 5, you see here, this is the minus, means it is towards the left side. This is right hand side of the S plane. This is the left side of the S plane. Therefore at -5 means at -5 centroid is -5. Here this is one branch tends to infinity at angle 60 degree. One more is at what degree? 180 degree. This is 160 degree. One more is at 180 degree. One more at 300 degree. 300. And from this is how we can find out the three asymptotes and also the centroid. Afterwards we have to find out the breakaway point. From that we have to draw the root locus. From that we can come to know whether the system is stable or not. Therefore to find out the breakaway point, we have step number 5. Step number 5, what we have to do? We have to 1 plus g of s plus h of s equal to 0. Already we know that to calculate breakaway point we have to take like this. We already know that what is g of s, what is h of s. G of s and h of s are nothing but this is the equation. This is nothing but g of s h of s equal to k divided by s into s plus 5 s plus 10. Substitute this value in this equation. Therefore it will be 1 plus k divided by s into s plus 5 into s plus 10 equal to 0. Therefore rearrange this equation, take this multiply, then we'll get this equation. Therefore k equal to, take this all this left and right this in this side, right hand side, that all will become minus s of 3 minus 15s s square. Then take here, therefore then differentiate k with respect to s. When we differentiate k with respect to s, this will be 3s s of minus 3s s of 2 minus 30s minus 50 equal to 0. Then s of 2, take minus 3 common here, minus 3 common, then s of 2 s raised to 2 plus 10 plus 10 s plus when we take 3s 3 common, 3 minus 3 common, then when we common means 50 should be common here. Therefore we are left, when we divide it by 3, then the value will be 16 plus 60. Therefore we will get this equation. From this equation we can find out the that is we can find out that is what we can find out. That is, from that we'll come to know that is from that we'll calculate 1 minute. That is, from this we'll get the equation. This equation, taking minus 3 common, minus 3 common, then when we take minus 3 common, we'll get this equation. Minus 3 common, we'll get this equation. Then to calculate the root of this equation using the equation that is in the previous class, we know how we can find out the root of equation. That is, some equation is there to find out the root of the equation. That is the root of the equation. What is the equation for to calculate the root? That is to calculate the root of the equation, this is the s equal to s equal to s equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Hmm. We can calculate the root of the equation, that is s equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Using this formula we can find out the root of the value of s, that is minus b. Here what is this? Is b, this is a, the term b, this is c. Therefore to find out the root of the value of s equal to minus b plus or minus square root of b square minus 4ac. A value is what is coefficient of this 1. Therefore what is the c is nothing but 16 point, this one 4 into that way divided by 2 to a is 1. Therefore this is, from this we can find out the root of the value of the equation, that is the value of the s. Therefore then you minus 10 plus or minus, take all the values, do the calculation, you will get the value of s as minus 2.13 minus 7.8. Two values. Why? Because plus or minus is there. Therefore using this we will get the values of s as minus 2.113, one more value is minus 7.88. Therefore thus s is equal to minus 2.113 is a valid breakaway point. Here we will take the value of breakaway point as minus 2.113. We will not consider the breakaway point as minus 7.88, because before that only we have assumed, that is what we have assumed, the breakaway point will be somewhere around, that is minus 5 and 0. It should not be between this only breakaway point possibility. It should not, minus means it is not a breakaway point. Therefore here two values are there, therefore we have to consider minus 2 means, to minus 2 will be, minus 2 will be in between the minus 5 and 0. Minus 7 is not in between minus 5 and 0, it will come somewhere, it will be here, that will be not the breakaway point. Therefore from this equation we will consider minus 2.113 as a breakaway point. Thus s equal to minus 2.1 is a valid breakaway point. Once we find out the value of the breakaway point, substitute that value in equation 1. This is the equation 1. Substituting in equation 1, where is 1 here, this in this equation, k equal to minus s3 minus 15s square minus 50, in that substitute the value of s as minus 2.13. Therefore we'll get the value of k as plus 48.112. Therefore k is equal to 48.1 for the value of s. What is the breakaway point value? That is minus 2.113. Then after that what we have to find out, as k is positive, that is how much, 48, and that is plus 48, and therefore as k is positive and s is value is s is equal to minus 2.113 is a valid breakaway point. Then step number 6, intersection with negative real axis, intersection with the negative real axis. Therefore s3 plus 15 s square plus 50 s plus k equal to, here this equation 60 s cube s raised to 3 plus 15 s square plus 15 s plus k equal to 0. Take this equation from this using using the roots criteria will find out the coefficients value. From this we'll substitute the values of this like this. From that we'll come to know that is from row of s1 will come to know s50 minus k equal to 0. Therefore from this row will come to know s50 minus k equal to 0. Therefore k m mar k, this is marginal. One more root locus here root locus, this is one more marginal root locus value will be at k equal to 750. Therefore as equal to 15 s square plus k 50, where this is s square means from this above equation, this is 15 s square plus k. 15 as equal to this is auxiliary equation. In the root-Hurwitz criteria discuss these concepts. as equal to 15 s square plus k equal to 0. Therefore 15 s square plus k, here we have to find k value marginal, we have considered that k value as 750. Therefore in this equation substitute the value of k as 750. Therefore 15 s square plus 750 equal to 0. Therefore s square equal to, take this side, therefore minus 750 divided by 15. Therefore s square, therefore s square is equal to minus 50. Therefore s is equal to plus or minus j, s square is equal to minus 50. What is the value of s? S equal to plus or minus j square root of 50. Why here the term j comes? Because minus is there. Therefore what is the value of s? S will be plus or minus j square root of 50, and that will be plus or minus j 7.071. j means the imaginary value, this is imaginary part. And therefore step number 7, no complex poles, hence angles of departure not required. Root locus breaks at plus and minus 90 degree at breakaway point. Then step number 8, the complete root locus is shown in the figure. The complete root locus, first we have find out here one root locus diagram. Here that is the centroid, the asymptotes at the angle of 60 degree, at the angle of 180 degree, at the angle of 300 degree. One more here, one more root locus, one more diagram is that we have find out the value of the, that is breakaway point, that is minus 2 point minus 2 point minus 2.113, and also the angles as the values are plus or minus values of intersection of with the imaginary axis, those values are plus or minus j equal to 7.07. That is this with 90 at the angle of 90 degree. That is here they are written, you see the breaks at 90 degree plus or minus 90 degree at breakaway. Therefore the breakaway points of this root locus, the breakaway point is 1 is here at what value? Minus 2.113. This is the breakaway point here, and this cuts this imaginary axis at 90 degree. 90 degree means here plus 90 degree minus 90 degree. This is 90 degree 90 degree, and what are the values? What are the values of yes? They should be here. This plus j 7.071, here minus j 7.07, because the values will be plus or minus. Therefore take one point here, take one point here, take one point here, take one point here, and draw the graph like this. You will get one the root locus diagram. This is the value. This is k marginal value of root locus diagram. This is one here, one more this like this, minus j 7.071, the breakaway point at minus 2.113 plus j 7.071, like this. One more root locus diagram related to the given expression. From this, the comment, what we give the comment on the stability from this diagram. For 0 less than k less than 50, system is stable as entire root locus in the left half of the s plane. Therefore, if here the root locus is left of the s plane, the system will be stable. If it is the root locus or diagram, the breakaway point, everything, the diagram is towards the right side, then the system will be unstable. Suppose it is there on the axis, then at that time we can say that the system will be marginally stable. It is, we are not accurately say it is full stable or absolutely stable, or it is not unstable, it is marginally stable. Therefore, for 0 less than k less than 70, system is stable as entire root locus in the left half of the s plane at k is equal to 750. You see, now suppose k is equal to 750, the system, we can say it is marginally stable. Suppose for 750 less than k less than infinity, then at that time we can say that the system is unstable. This is because the dominant roots move towards the right half of the s plane. If the dominant roots, if they are towards the right of the s plane here, then the system will not be stable. From why we draw this root locus, or what is root locus diagram means, from this diagram we'll come to know whether the system is stable or not. That is, stability is predicted by the locations of the dominant roots. The dominant roots are those which are located closest to the imaginary axis. The branches starting from such roots which are dominant decides the stability of the system. Stability, how we can find out system stable or not? That is, using such problems may be also may be asked in the exam. Definitely, for example, will give this equation. From this, they will from this equation they ask you to find out, draw the approximate root locus diagram of a closed loop system whose loop transfer function is given by this equation, and comment on the stability. From this equation we have to do all these steps. From all these steps we have to find out all this, that is about breakaway point, you have to find out the centroid, you have to find out the angle of symptotus. So many calculations are there. Finally we'll get this diagram. This diagram is nothing but the root locus diagram of a particular system. From this, we'll come to know whether the system is stable or not, whether it's absolutely stable, or it is marginally stable, or it is unstable. Everything we will decide by seeing this diagram. It's important. Such questions definitely they will ask in exam. Fifth module, definitely they will ask only on these concepts. One is root Hurwitz criteria. One question related to root locus criteria. One question related to Bode plot. Over only, and also the syllabus for fifth module is only the syllabus is only belonging to these three concepts only. Okay, this is about the root locus criteria. In the next, this is about root locus criteria. In the previous video lecture, I have discussed about root Hurwitz criteria. In next video lecture, I will discuss about the Bode plot. Bode plot. I will discuss. Means all it is as good as we have discussed all the concepts related to fifth module. Okay, okay. Thank you.